to section 3.1. We're going to work on day 2 stuff. So all we're going to be doing tonight is a little extra practice to make sure that we're set. Now I've got some that are a little bit more difficult as we go through. So I want to start, and now you'll notice as you look at this notes that we have one example in the top, and then I give you one in the bottom for yourself. In order to get the notes points for tonight, you have to complete the one that's on your own, or the 2 that are on your own, showing me that you were able to at least practice or give me a good attempt. Okay, so let's start with the first one, and these are nice and easy. They're both set for us in terms of y equals. So what we're going to do is start graphing these. If I look at the first one, the -1 is where I start. So on the y-axis, I go down to -1 and I put my first dot. If I look at my slope, the slope is 4, which we know is the fraction 4 over 1, and that says go up 4 and over 1. So 1, 2, 3, 4 up over 1. And we again start at that -1 in order to do it. Now, since I can't go up 4 and over 1 more time and still stay on my graph, let's try going down 4 and left 1. So down 1, 2, 3, 4, left 1. And that gives us at least a few points on there to make our line. Now again, with your homework, you'll get another 10 by 10 grid, so you'll be able to do more than just 3 points. But kind of keep that in mind as I look. I extend my line and put arrows. And there's my first line. Now, like I did yesterday, I'm going to change my color a minute so that we can do our second one. If you look at the second example, or the second equation in our system, you'll notice that there's no b. And so what I'm going to do is put a +0 on there so that you can kind of see that we're supposed to start at 0, 0. And now I'm going to go up 3 and over 1 according to my slope. So up 3 over 1. Oh, nice. Up 3 I can't, so let's go down 3 and left 1. And I could keep going if I wanted. Down 3 and left 1. And I could go up 1, 2, 3 and over 1. And you're going to kind of see, that would be nice if I actually had the right point there. Let me change that. Up 1, 2, 3 and over 1 puts us over here. So you can kind of see these kind of run pretty close together for a while. They will end up changing, but you can see our point of intersection is at the point over 1 up 3. So 1, 3. This is our solution. If I were to label my system, though, I would say this system, because it intersects, is consistent, and because it intersects only once, it's independent. Okay, so what we're going to have you do for the one on your own, obviously you're going to have to solve for y first. And then once you do that, we want you to put your system on your graph and then label its solution and classify the system. Okay, so there's the first one. The one next gets a little bit harder. And so what we're going to do is solve for y in each of these. So I'm going to set my first equation, -2x plus y equals 4. And if we go back to yesterday, to move the 2x, it's negative. So I'm going to add 2x to both sides. Add 2x. Now let's get rid of it. So I have y equals a +2x plus 4. So if I go to graph this, this says go up to the 4 on my y-axis. And then my slope is 2 over 1, so up 2 over 1. Now you'll notice on my graph I could go up 2 and over 1, it would probably be right about here. But let's get some points actually on the graph. Instead of going up 2, let's go down 2 and left 1. Down 2 and left 1, down 2 and left 1, down 2 and left 1. And you'll notice again I'm just doing the opposite. And so we connect our line and extend it, and we get this first line. Let me change colors for my second graph. 4x minus 2y equals negative 8. So the 4 is positive, so I'm going to subtract 4. So I have negative 2y equals negative 4x, and then I had a negative 8, so minus 8. I'm going to divide every number by the negative 2 that's in front of the y. Negative 2, and that goes away. So negative 4 divided by negative 2 is a positive 2 with an x. Negative 8 divided by negative 2 is a positive 4. Ding, 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 ding. You should look at this and see that these are exactly the same. So I know that I have, let's try that again. My pen's not working. Let's try infinitely many solutions. Infinitely many solutions. And if that's the case, let me label my system. I can label my system, because I have solutions, I can call it consistent. But because there are infinitely many solutions, I say it's consistent and dependent. Okay? Now again, you're going to do the one that's on your own. You obviously will have to solve for y. But this is at least general idea, and we've done enough practice both in class and here on the notes that you guys should be fine. We're going to look lastly at the story problem, and we're going to figure out then graphing wise, what do we do? So I'm going to move my sheet over. All right, a soccer league offers 2 options for the membership plan. The first option includes an initial fee of $40 and a cost of $5 per game for each game. That means our variable of x is going to go there, okay? And if I write my first one, we're going to say a cost is, let's use y. So we're going to say for option A, y equals, it costs me $40 no matter what, plus, and means plus, $5 per game. So that's option A. Option B is just $10 per game. So option B, $10 per game is where my variable goes, so it's 10 times x. When will the 2 options cost the same amount? Now you'll notice I hadn't put a graph on here, and the number one reason why is because a 10 by 10 grid is not going to be good if I need to get up to 40. So here's what I'm going to do. These are both in terms of y, which is really nice. So I'm going to try and make my graph here with you. And you'll notice I don't need any negative numbers because we never play negative games. So, and I shouldn't have to have negative money either. So I'm looking at this. And let's start talking about what we want to do. All right, I know I have to go up to 40, but then I'm also going to have to pay $5 more each game. So I need to go higher than 40. Okay, so let's do this. Let's go 10, 20, 30, 40. Let's go up to 60 and see if that works. So 50 and 60. Now if you wanted, you could put the little hash marks in there for 5s. 5, 5. Since I know I'm going up by 5s, that's what I would do. On the other line, we're talking about numbers of games, and I'm going to go in single digits. And you can go up in different scales as long on each axis if you want. So I'm going to go, here's game 1, game 2, 3, 4, 5, let's go to 6. Now I have not graphed this one before, so we're going to do this kind of together as we go through. But here's what I want to do. Let me change my colors, and I'm going to say this first one is going to be in this purpley blue color. that means I start at 40 because it's the same thing as 5x plus 40. Okay, so I start at 40, and then what it says for my slope is go up 5 for every one I go over. So I'm going to go up 5, which is what our marker is, and then over 1. Okay, and I'm going to go up to 50 over to 2. Up to 55 over to 3. Up to 60 over to 4. And you're starting to see, again, I apologize for the accuracy, a line that looks kind of like that. Okay. In our second graph, which let me change my color again. How about a green? In my second graph, you'll notice there's no b, so I could add a plus 0, which means I'm starting at 0, 0. Now this says go up 10 for every one I go over. So up 10 over 1, up to 20 over 2, up to 30 over 3, up to 40 over 4, up to 50 over 5, up to 60 over 7, or over 6. I would go up to 70 over 7. Guess we're going to have to go a little farther, huh? Up to 80 would be 8. So let me extend this. See, again, we're doing this together. So this is what I would do if it were me as I'm going through. And I obviously am going to have to keep looking. So, okay, let me do it this way. I look here, and I kind of extend my line, right? Let me go back and try and get that color or something at least close, because we're going to have to keep going on our other one. So we were at 460, which means we got to go up 5 over to 5, up to 70 over to 6, up to 75 over to 7, there we go, up to 80 over to 8. So I'd have to extend this a little bit more. And so what we're seeing, again, I don't have the nice grid marks like we do in the 10 by 10 grids, and that's really what you need for some of these, but as you look, what it says is 880 is our solution. What that means is at 8 games, both options, oh, my pen's acting up. Both options equal $80, okay? And you can kind of look at it this way. Again, some of the story problems are harder just in the fact that when we're trying to graph it, our graph is not this nice 10 by 10 grid. And that's one of the hardest parts about these. And so what we're going to do for a story problem on something like a quiz or a test, what we would do is give you the grid at least for you to fill out. So the graph would already be there. You would just have to plot the points along the way. Okay? So that's it for section 3.1. That's the end of 3.1. What we're going to do is practice a little bit more in class tomorrow, and then go from there, and we'll show you then in tomorrow's video a way to do it without having to graph. Okay, so we've got one more day of graphing, and then we'll kind of show you other options. So thanks for watching.